My name is Dave Mesecher. I'll be moderating the session. And our first speaker is Dr. Yu Yang. He is a assistant professor at Lehigh University in the Department of Computer Science and Engineering. And he's going to be speaking on cyber physical systems for on-demand delivery. Please welcome Dr. Yang.
Thank you, Dave. Thank you. I hope, can you hear me? Right.
I can hear you.
Yeah. Let me share my screen. Can you see my screen good?
Yep.
Okay, perfect. All right, let's get started. Okay, hi everyone. So my name is Yu Yang. I'm an assistant professor at Lehigh University. And today is my great pleasure to be here to introduce our recent research work about cyber physical systems for on-demand delivery. So let's first go through some background about on-demand delivery first. So nowadays, on-demand delivery service is a very common service to buy food or groceries. So especially during the pandemic, it plays an important role to meet people's daily needs. So in 2020, the market value of on-demand delivery is around $42 billion, and it is expected to increase to be more than $200 billion in 2027. In this large market, we have many service providers. For example, in US, we have Amazon, DoorDash, Uber Eats, and Instacart. In other countries, we also have similar services. Despite the different service providers, we can see a similar work pipeline of the delivery. In general, the delivery service can be simplified as a progress from placing an order to the final delivery. In this process, a customer first places the order to a server, then the server dispatches the order to a worker. Then the worker moves to the nearby store to pick up the order. In some cases, this store can be in a multi-story mall. When the worker arrives at the store, the worker will report the pickup time on their smartphone app. Finally, the worker delivers the order to the destination and also report the delivery time to the server. In this process, a key goal is to make the delivery in a short time because the delivery time impacts customers' experience a lot and even impacts the food taste. If we take a closer look at this process, we can actually divide this process into two parts, including the cyber process and the physical process. In the cyber process, most of the work is done in the cyber world, which only costs a few seconds, like this kind of internet transmission. But in the physical process, the worker has to move around the city, which costs the majority of the time. This indicates that it is more promising to reduce the delivery time by optimizing the physical process. If we look at the physical process, the most important information is the pickup time. With the pickup time, we can do many things. For example, customers can have better experience of knowing the status of the order. The platform can make better scheduling to improve the workers' efficiency. However, the problem is that currently all these kind of delivery services rely on the manual report from workers, which leads to inaccurate reported pickup time. For example, this figure shows the distribution of the reported pickup time error in one of the largest on-demand delivery platform. The x-axis of this figure is the error of the reported pickup time, and the y-axis is the percentage of the orders. We can see that like only around 28% of the orders is with the error is within 1 minute, which we might consider as accurate. But 19% of the orders have errors greater than 10 minutes, which dramatically affects the delivery scheduling efficiency, considering that we have a deadline of roughly 30 minutes in many services. To solve this problem, we designed a solution called A-Beacon, which is a hybrid solution for human status sensing and prediction in the wild. This is a joint work with both the academia and industry. We also deployed this solution in Alibaba, which provides one of the largest on-demand delivery services in China. In this hybrid solution, we designed 3 systems, including a physical beacon system, a virtual beacon system, and a beacon-free system. I will briefly introduce the key idea in these systems. So let's first take a look at the goal of our solution. Our goal is that we want to achieve reliable time inference at a large-scale platform. To this end, we need to achieve two objectives: reliability and scalability. For reliability, we want our solution to have high accuracy, and for scalability, our solution should have low cost and also high generalizability to different locations. There are a lot of related work in this direction. If we use a reliability and scalability, we can put them into this coordinate system. The most commonly used solutions are based on GPS and Wi-Fi, but we all know GPS has low accuracy in the indoor environments, and using Wi-Fi requires a fingerprint database and manual calibration. Some recent work use RFID and LED, which provide high reliability, but they all need extra hardware deployment, which leads to low scalability. Compared to them, a more promising solution is to use Bluetooth, which achieves better trade-off between scalability and reliability. Based on this, let's look at our first Bluetooth-based system, physical beacon system. Basically, to use Bluetooth, we need to deploy a physical beacon in the store. The physical beacon starts to broadcast Bluetooth signal, including its device ID. When a worker's smartphone is nearby and detects the signal, then the smartphone uploads the device ID to the server. Finally, the server will know the location of the worker based on the pre-stored device and store mapping to perform the time inference. Based on this design, we deploy this system with 4 phases, including conception, deployment, operation, and finally retirement. The x-axis of this figure is the, I think I got the right slide. Okay, the x-axis of this figure is the time, and the y-axis is the number of active devices. In the conception phase, we first test our solution in 18 stores by directly using different commodity devices. After we see some preliminary results, we customize one of the devices to reduce the cost and deploy 400 devices in 400 stores. These customized devices are powered by 2A battery and only has a Bluetooth broadcasting module. This figure shows the heat map after we deploy these customized devices in Chinese city Shanghai. In the second phase, we start to deploy the devices in the whole city. In total, we deployed 12,000 devices in the city, which occupy around 21% of the stores. This figure shows the heat map after the full deployment. So after the deployment, we come to the operation phase. In the operation phase, we have 2 observations. One is that we find there is a continuous decrease of the number of our active devices. For example, after 1.5 years, we see the number of the devices is decreased to 11,000. Even worse, we observe a sudden decrease later. In April 2020, there are only around 100 devices left. To understand the reason, we analyze the lifetime of the device and the stores. This figure shows the comparison between the device lifetime and the store lifetime. The x-axis is the device lifetime and the y-axis is the store lifetime. Each point in this figure represents a store. For example, in this point, the store lifetime is longer than the device. This may be a result that the merchant removes the device when in decoration. In this case, the workers cannot detect the signal of the device anymore. In another point, the store lifetime is shorter than the device. This may be because the merchants leave our platform or the store is closed, but the device is still there. Then the pass-by workers can still detect the signal from the device. A special case is along this diagonal, where the store and the device have the same lifetime. This is because when some stores leave the platform, and they also remove the devices at the same time. Basically, we can see along the x-axis, there are devices become inactive and or undetectable almost every day. This explains why we see this continuous decrease. Another observation is that there are a large number of devices stop working at around 2 years. This is mainly because the battery is running out. This explains why we see the sudden decrease in the trend. Overall, we see it shows the system lifetime depends not only on the battery lifetime, but also the environment lifetime. A simple solution is just to replace all the devices or replace all the batteries in a city by every 2 years. This may be okay for a single city, but if we want to scale up the number of the cities to be 100, then we need to replace a city every 7 days on average. Even worse, our platform serves more than 300 cities, then we need to replace a city every 2 days. This problem leads to a low scalability of the physical beacon system. To solve this limitation, we introduce our second system, a virtual beacon system. The question we're trying to answer is that, can we somehow avoid this lifetime limitation of these devices? Ideally, we want no battery issues, and also the devices can have the same lifetime as the stores. The opportunity of solving this problem is that we found that most of the merchants accept orders using smartphones. If they allow us to use their smartphones as virtual beacons that broadcast Bluetooth, that would bring great convenience for us. To use this opportunity, the key challenge is that we need to motivate the participation of merchants, considering about both the benefits and the cost. For the benefits, merchants care about if they can earn more customers or make more profit, for example, with better delivery efficiency. For the cost, the merchants may worry about the energy consumption and also the privacy risk. To solve this challenge, we did the following design to maximize the benefits and minimize the cost. Basically, we use a similar design framework as our physical beacon system, so we can keep consistency when we are doing this system transition. The only change is that we replaced the previously customized devices with the smartphones from merchants. To save the energy cost, we adapt the broadcast frequency according to the number of orders. For example, make it silent if there is no order. To protect the privacy, we use the dynamic ID generation to hide owner's ID, and also the owner can turn on or turn off the broadcasting module by any time. Based on this design, we deploy the system at a large scale. Overall, this is the first nation-scale virtual beacon system with more than 3.3 million virtual beacon interacting with more than 1 million workers. The right heat map shows the distribution of the devices in China. In this system, we exploit the reliability and also the scalability in 3 different phases, including conception, deployment, and operation. We also report our lessons learned in this system in SIGCOMM 2021. To evaluate this system, we perform experiments on a number of metrics such as reliability, utility, energy, and re-identification ratio. Each of them is corresponding to one aspect of the benefits and cost. I don't have enough time to show them all, but I want to emphasize the final result: how many merchants participate in our system. So this figure shows the participation rate of merchants with different experience in the platform. So basically, we see that we can have around 85% of the participation rate. So we expect workers with different experience may result in certain pattern of the participation rate, but the results shows there is no obvious correlation. So this 85% of participation rate is good for a system in this large scale, but we want to go one more step. So how we can solve the problem if a merchant not participate in the system? So that is, how do we achieve the time inference without any beacon devices, no matter it's a physical beacon or a virtual beacon? To answer this question, we introduce the third system called a beacon-free system. So remember, the key reason for the inaccurate pickup time reporting is because the workers did not report as we expected. This motivates us to consider the reported pickup time as a result of human behavior. This leads to our idea to learn reporting behavior using machine learning. If we can learn human behavior by a function that inputs the reported pickup time and the outputs the actual pickup time, then we can solve this problem. Our opportunity is that we have rich reporting behavior data collected from workers, which is one part of our input. We also have the large-scale GPS data of workers, which provides us some context as another part of the input. The challenge is that if we do not assume the existing beacon systems, we do not have a way to collect the training labels. To solve this challenge, we designed our beacon-free system. So this is the first work of reporting behavior learning for on-demand delivery. We learn the reporting behavior based on transfer learning between certain and uncertain environments. We also build self-labeling process based on the boundary of the certain and uncertain environments. Some environment constraints are also designed based on our data-driven investigation. Finally, we evaluate it with more than 500 workers, and the right figure shows our test bed and the workers' GPS nearby. Our results shows that our system can outperform the several commercial baselines by 75% more accuracy. It can also achieve competitive results with label-intensive solutions, which are generally very challenging to be deployed at large scale. We report our results in Mobicom 2020, so welcome to check the details in our paper. So with that, I would like to conclude my talk with a general framework. For any system to detect a human status, we can go for a sophisticated hardware solution that is our physical beacon system. The accuracy of this kind of system is good because all these kind of systems have standard or the same hardware segment, which is much convenient for control the accuracy. But the problem is that these kind of devices generally have high cost if we deploy them at a large scale. So this brings the low scalability of this kind of hardware-based system. Then we can think about a software-based solution. So with the existing devices, like in our situation, we use the merchant smartphones as the existing devices. In this case, we don't need to deploy any hardware devices. So this provides high scalability of this kind of system, but it also has its own cost, such as participation. So we cannot control or force all the merchants to participate in our system. To avoid this kind of constraint, we introduce human behavior model-based solution, so which is our beacon-free system. By utilizing the existing data in our system, we can model the human reporting behavior to achieve accurate results of this kind of pickup reporting time. So these three systems work together as a hybrid solution to deal with the challenges in different situations. So with that, I will stop my presentation, and I'm happy to answer any questions. Thank you.
Thank you, Dr. Yang. Excellent presentation. Do we have any questions from the audience? I don't see any questions in the QA section, but so Dr. Yang, I was wondering, for your beacon-free solution, is there an impact on the effectiveness of that solution based on how much training is given to the workers that work for the merchants?
Yeah, thank you for the question. I think for this, I'm sorry, I hear some echo. Okay, so for this solution, so the human behavior is more about the workers' human behavior. So it's like how the workers report the pickup time when they arrive or nearby the merchants. In that case, we do not require the participation of the merchants. So in this way, we can avoid the limitation of this kind of software-based solution that require the participation of the smartphones from the merchants.
Effectively eliminates the need for any training.
Right, exactly. So we only use the existing data collected in our server from our workers side instead of from the merchant side to limit the necessary to require the participation of the merchants.
How do you anticipate the rollout of these solutions in rural areas?
Yeah, I think that's an excellent question. So let me share my screen since Bing is asking me to stop sharing. Let me see. Okay, cool. Okay, for that question right now, so the major cities we are serving is in the large cities in China. So like I mentioned, we serve around more than 300 cities. In the rural area, I think the key challenge is that if there is enough or sufficient data for us to train this kind of model, because in large cities we all have like this kind of millions of the orders every day, but for rural areas, so the problem is that we have like enough customers to place this kind of order for us to collect the data. So one potential solution is like we can consider to transfer the model we trained in the large cities to the to the rural area or smaller cities. But we didn't test that yet. But I believe that's one good direction to go for.
Okay, that makes sense. I don't think there are any questions from the audience. So I'd like to thank you, Dr. Yang, and I appreciate your presentation.
All right, thank you.
So our next presenter is Bob Friday, and he is the CTO and co-founder of Mist Systems. And he is going to be speaking to us on how AI ML is disrupting the network industry, a data-driven approach to IT operations. Please welcome Mr. Friday.
Well, thank you, everyone. It's it's an honor to be at this year's conference. I'm Bob Friday, currently CTO of Mist Systems. I've done 3 wireless startups, so I'm a wireless entrepreneur at heart. And I'm here today to kind of talk about how I see AI ML changing mobile networking over my career here. I work with a lot of enterprise customers right now, and I think we're all starting to see it in our lives, how AI ML is changing different aspects. Right now I'm working with a lot of hospitals. They're starting to talk about taking Boston Robotics robots into the hospital for doing cleaning. These are robots that can open doors and shut doors. So in healthcare, we're seeing some major changes. We're seeing really around prediction, right? Getting better at predicting cancer. In Vegas, they're starting to have these automated buses. So that's even starting to show up in real life. And even in our grocery stores, I work with a lot of grocery customers that are starting to use this AI robotics, to go around for shelf stocking shelves. So we're starting to see that in a lot of different industries. Particularly for me, my career started in the 80s. And I tell people I send the FCC a Christmas card every year because I started when the FCC released this unlicensed spectrum for Wi-Fi. Originally, Wi-Fi became that Wi-Fi was built on. And when you look at the networking over our, for people like my age, over our lifetime, right? I can remember when I was happy to get a 9 dots internet connection, and what we're seeing right now, we're starting to see mobility become a bigger part of our lives. And we're starting to see it become the whole networking aspect. When you connect to the internet or to the cloud, that whole connection is getting more complex as applications get distributed out to the internet and out to the cloud. And what's even getting more complex is on one side, we've had this Wi-Fi world. And then on the other side, we've had our public cellular world. And now we have a new kid on the block, private cellular. The FCC has released new spectrum now that's going to let our enterprise and our schools start to deploy another form of wireless network for our mobile applications. And you look at where this is headed, and I always give the analogy that for me, wireless, is kind of like stochastic random variables. If you look at the wired networks, it's kind of like algebra. Wired is a very deterministic black and white. When something breaks, it kind of stays broken. But when you look at wireless is kind of much more variable. When something breaks, if you wait 5 minutes, it may start working. So what you're seeing is the world is becoming much more mobility. If you look at the Cisco data where we're headed, probably 75% of all data is going to be on some mobile network. About half of that's going to be on Wi-Fi. Another 20% is going to be on these cellular networks. So what it's really telling us is these mobile networks are getting much more complicated in nature, and they're driving a lot more economics, right? They're becoming much more relevant to different industries right now economically. And the interesting thing I found, when you look at these mobile networks, you look at power and white, they're, mobility and wireless is becoming on par with electricity and water, right? If you look at the population right around the world, it's kind of amazing. 10% of the population doesn't have clean water, electricity, but you can see that mobile internet is becoming this economic necessity, for most governments. Where 60% of our population is going to have mobile internet here in the next couple of years. So you can kind of see where, as we start to economically, from a network point of view, this is becoming kind of an issue with a governmental issue with countries, right? For a country to be economically competitive, its networking is getting much more complex. It's getting much more complex and getting much more mobile. For myself, what I found is my last startup was aerospace in the early 2000s. And what I learned during that startup, that we were really focused on trying to help enterprise customers deal and manage with their wireless networks. That was back, and for those who remember, back in the 2000s, that's when Wi-Fi was just starting to become a nice to have in the enterprise, in the universities. And when you started that journey, it was really around trying to help them manage devices. My last startup, Mist, was back 2014. What I saw happen was wireless go from a nice to have to a must have to business critical now, to really a paradigm shift where we're moving from managing network devices to where we're really managing this end-to-end user experience. And when I started Mist in 2000, the reason I actually built an access point was to make sure it wasn't because of the connectivity portion. It turned out that the access point had the data that I needed to answer the question of, if you're having a bad internet experience, why are you having a bad internet experience? To answer that question, you really have to have data, from the edge of the network. And that's the reason why I built an access point, was to make sure I could actually get the data. It's not that I thought the industry needed another Wi-Fi access point. It's really because I wanted to be able to solve the problem of answering the question of, why are you having a bad internet experience? And for those who kind of remember the Watson playing Jeopardy, that was kind of the inspiration for Mist. It was like, if they can build something that can play Jeopardy on par with Jeopardy champions, we should be able to build a solution that can actually manage and troubleshoot networks on par with human domain experts. And that starts with data. And what I found in this journey is getting the data is probably one of the hardest things, to get done. To make sure you can answer a question or do something on par with a human, you need to make sure you can actually get the data you need to answer that question. And two, you have to get data to the cloud. And interesting, what I found with customers is that just getting that step done, getting the right data you needed to the cloud to answer a question and into a framework that you could apply data science to, customers alone appreciated that, because for the very first time, customers now were able to actually get access. They didn't have to log into devices, switches, APs, or routers. They actually get the data they needed in the cloud. Now, the next big part, and we'll talk about this a little bit, is the data science. Is once you have the data in the cloud, what do you do with it? And we'll talk about that in a little bit here. Probably the other big part I invest a lot of time in is really around conversational interfaces. Because if you're really going to build something that can do something on par with a human, you need to be able to have that virtual AI assistant join a team of humans. And really, you need to be able to figure out how to get people to trust your AI. And this is probably the biggest thing I've seen with customers and in the industry in general, is this AI hype, right? What's the difference between marketing AI hype and actual reality? And really, it's about making sure that you can build something that really a team of IT people can actually learn to trust on par, similar to what the human's doing. And then finally, you actually have to build something, give it a framework on which you can take an action, right? Even if you get the right answer, if your AI assistant gets the right answer, you have to give the humans a chance to basically decide whether or not they want to trust your AI assistant to actually execute or do anything with that answer long term. So these are kind of all the key components I've built, at MIST now to actually build something that can manage and troubleshoot a network on par with human domain experts. And this kind of shows you, interestingly, in the networking space, this AI ops paradigm. We started with the wireless piece of the network, because if you're trying to answer the question of why are humans, why is someone having a bad internet connection, it turns out that the access point or the wireless edge has a lot of the information to answer that question. But if you want to start to answer questions like, why are you having a bad Zoom experience or a bad application experience, then you need to start ingesting data from the router side. So the edge has a lot of the layer 2 connectivity information you need to answer questions, but the router has all the layer 3 session data you need to answer questions. And then you also want to be able to get data from the client side. You also want to get the client's view of the data. So then you want to start putting little pieces of code on that client to actually start feeding data back into the back end. And what you'll learn, on this journey is, should you go with what they call domain specific AI ops, which is what we're doing. We're starting with a very particular domain like networking and solving the networking problem. Or should you start with a domain agnostic approach? Should you buy some sort of AI ML platform that's designed to basically solve time series anomaly detections in general? My position right now is, say, for ROI, you really want to be very focused on what domain you're solving. You'll find out that the AI ML modeling is only a very small aspect of the whole problem. There's a whole feature engineering that goes along with solving these AI problems. And this is probably the one point, I would make is, people always ask me, what's the difference between AI and ML? For me, myself, when I talk to people about AI is really about trying to build something that does something on par with a human. Whereas ML is really, a technique or algorithm for solving problems. So there's a lot of problems you can solve with machine learning algorithms that really don't lead to AI. In this particular case, the problem I'm working on, or we're working on here, is really around, trying to build something that does something on par with a human IT domain expert that can really troubleshoot and manage networks on par with humans. This kind of highlights the fact, when you actually try to build something that's doing something on par with a human, it's usually not just one algorithm. There's usually a series of algorithms that are under the hood that are really doing that. And what this graph here tries to highlight is, why did we finally get this, when did this deep learning really come onto play? When did AI ML really go from research marketing hype, to something that can actually be useful in the industry? And what we saw from here is it was right around 2014. And I would say the big inflection point here was really around when we got enough data and these neural networks started to make a difference in our industry. And you kind of see it came around with computer vision, right? A lot of computer vision algorithms, and we got these convolutional neural networks big enough, they started to be able to do useful things around computer vision. For me in the networking space, if you look at the problems we're solving right now, I would say LSTM was probably one of the bigger differentiator in the networking space. When we're dealing with thousands of events and signals, it's really when we went to LSTM that we really were able to start to solve, time series anomaly detections with enough low false positives to make a difference for an IT person. Probably, the other big thing is if you look at these decision tree XG boost type of algorithms, we're using those algorithms here to really try to predict someone's internet speed. And that's one of the challenges with these deep learning networks is usually they give you good answers, but they may not tell you why. Whereas kind of a more classical decision tree algorithm is much more explainable. If you're trying to predict someone's throughput, you want to know why it's slow, right? If you're predicting low internet throughput, you want to know why it's slow. But then there's other algorithms like regression testing, right? These very classic regression algorithms have been around for a long time. Some of these algorithms are good for solving things like just identifying bad cables in networks. So it's really a combination of all these algorithms put together to really do something on par with a human that's happening. And I think you'll see this true whether it's autonomous cars or robots in healthcare. It's a series of these algorithms that you're putting together to do something. Yeah. And this is kind of an example on my journey, personal journey here at MIST, where we spent a lot of time trying to get this anomaly detection to work. We started with the simple moving average algorithms. That led to kind of 50% accuracy. Then we went to more a complicated moving average or REMA type of algorithms, and we got maybe the false positives up to 80%. It really wasn't until we got to these LSTM neural networks where we really were able to get the false positive down to like 1%, closer to 100% accuracy. And this is critical if you're trying to build something. If you're going to wake someone up at 3 a.m, you better be pretty sure that you're waking them up for a good reason. So this is an example in networking where these deep neural networks are starting to make a big difference in our networking space. I would say the other big algorithm that's probably starting to make a big difference for us is, really around conversational interfacing, around long former and few shots for people who are working in the NLP space. This is a space that actually has a lot of room for growth, and it's changing, pretty radically as we go forward here in the next couple of years. The other thing I wanted to kind of touch upon is, there's the model itself. If you're trying to build a company, like I'm here, getting MIST built, it's one thing to get data scientists who actually understand the models and all the math and statistics and everything. It's probably even more important to really get the organization correct. When you're working on problems, whether it's networking, healthcare, or self-driving cars, you've got to start getting the data science team connected with the domain experts. What I found is, trying to build models that work in production and do something useful for a customer, you really have to organizationally get your data science team connected with your domain experts. Here at MIST, we did that by getting the data science team connected right into our customer success team, who really understood the customer, the actual domain problem we're solved, and really got that feedback loop organizationally. So those two teams actually are tied to the hip, working side by side together every day. So this is one of the key things, for people who are actually, in building algorithms that go into production. I think, you can relate to the fact, probably 10% of the work is getting the model to work. 90% of the work is in all the feature engineering and production and getting pipelines built to support those models. And with that, that's kind of a short summary of where I see AI ML basically disrupting the networking space. I think, what I'd leave you with is the big paradigm shift in networking right now is going from managing the actual individual network elements to actually starting to actually manage the end-to-end user application experience. And this is as we see these networks get much more complex. We're moving into a world where we're going to have multiple networks, whether it's Wi-Fi, cellular, private cellular. You really want your devices to keep you connected to the internet as simple as you can. And really, AI ops is really the beginnings of the complexity, is the answer to this complexity as we go forward. With that, I want to thank everyone and open to questions and offer, if you want to reach out to me, love to talk about stuff. Feel free to reach out to me on the link or my email here.
Thank you, Mr. Friday. That was an excellent presentation. I do see that we have a question from the audience, and that question says, could you underline the safety concerns about using cloud technologies while storing and processing data on the cloud, especially sensitive data?
Yeah, I mean, I think right now, and if you when you use the word safety, I'm going to interpret that to mean privacy, in terms of storing sensitive data. I would say, what we're working with, like governments like Department of Defense in that sense, even the Department of Defense are starting to move to cloud-based solutions. Now, there's a whole different security aspect, when you're working with a federal department or government department on how you deal with cloud solutions. and there we have things called FIPS. FIPS have been around. The government is starting to work on things called FedRAMP. So if you're in the cloud space, you'll get to know FedRAMP very clearly, which is basically dealing with how to securely do things in the cloud for government agencies, if that's what they meant by safety.
Yeah, it doesn't really specify what's meant by safety in the question, but that's probably a good assumption.
Yeah.
One question I had was, can you give an example, or do the algorithms that are optimizing the network performance, are they making changes to the network in real time, or can you give some examples of how they affect the network?
Yeah, probably the classic in the wireless network is what they call radio resource management. There's these reinforcement algorithms now that are basically looking at the user experience and constantly adjusting transmit power and channel assignments on the radios, right? That's probably the classic example of an algorithm that's actually adjusting knobs in real time. As we kind of move into switches on the WAN routers, that's probably another example with SD-WAN where the algorithms are starting out to adjust paths, right? Where you'll find you have much more, you'll have like multiple paths back to an application now. You may have 2 or 3 different data centers running the same app, and you may have different options to getting back to that application. So you're starting to see much more complicated paths back to your application. VPNs, they're starting to see, configuration. If someone trusts the algorithm enough, they'll start to let the AI assistant start to reconfigure missing VLANs, right?
Mm-hmm.
Start to find misconfigured VLANs in a network type of thing.
Okay, great. The first question, the person asked the first question came back and indicated, yes, he meant privacy. So,
yeah.
All right. And there are no further questions, so I'd like to thank you, Mr. Peters. I appreciate your presentation today.
Okay, no, thank you for having me.
So our final speaker for this session is Ido Aharoni, and he is a former ambassador, and he is also currently a global distinguished professor at NYU. And he is going to be speaking on information overload, its impact and long-term implications. So please welcome Mr. Aharoni.
First of all, it's a real pleasure to be here again. I'd like to thank all of you. My subject, of course, is not as technological. I'm not a scientist. I'm not an engineer. My expertise is government relations. I worked for governments for many years, and the big part of my job was to try and understand how people experience technology. And so the subject of my short presentation today is about information overload. Now, I don't have to tell this group that when you look at the evolution of society and an economy, obviously we went from being nomads to the agrarian era, industrial with automation, the industrial revolution. Now we're living through the technological revolution, that one of the main manifestations of the technological revolution is the fact that we all live in the age of information. The age of information is unprecedented in just about every aspect that you can look at, from the unprecedented access to information that we have today, the unprecedented speed in which we can retrieve the information, the unprecedented accuracy. Within a split of a second, you can get almost all the information that you need, and of course, the unprecedented volume, the abundance of information that we have out there. Now, the problem is that technology has exceeded evolution in the sense that human began to evolve about 7 million years ago, and our human brain was designed to allow us to survive. That's the reason why some sensory capabilities are more developed in different species. For example, we can see better than dogs, but dogs can hear better than us. This is because of survivability. And there were several stages of evolution, as you all know. But one thing we know about the way the brain functions, we know that the brain cannot effectively handle more than 2 or 3 complex related activities at once. This is based on an abundance of research. I have all the references if you'd like it. If you'd like me to share this with you after the presentation. So the human brain cannot perform several tasks simultaneously, which means really that multitasking is a myth. It doesn't really exist in reality. If you do attempt to multitask, it means that you will lower and reduce the level of your performance. Now, this is acutely important when we consider the amount of information that humankind is producing right now. So, for example, every day we create roughly 2.5 quintillion bytes of data, which means, I mean, I'm not an expert on all those terms, but I'm being told that an exabyte is equal to 1,000 petabytes or 1 billion gigabytes. A zettabyte is a unit of a digital information that is a trillion gigabytes. So this is the volume of information that we are producing as humankind. And all the indexed information is maybe less than 10% of all the information created and all the content produced by human beings out there. Now, when this revolution started, when the age of information really kicked in a very big way with the introduction of Google as a search engine, which was all about simplicity and efficiency. I don't have to tell you, Google was the 16th search engine to be introduced to the market, but it caught on because of its efficiency and simplicity. That one tagline became the brand, one search line. It wasn't about making all the information visibly accessible to you. It was about counting on you, the consumer, that you will know what you're looking for and giving you the ability to search, basically switching the roles of the database. So many intellectuals, when they looked at what was coming, they called it the decentralization of information, the bypassing of the traditional mediators. They spoke a lot about democratization of information, how information, the high proliferation of information is going to threaten authoritarian regimes. Why? Because by definition, ideas know no boundaries. And by definition, information and ideas will contribute to more transparency, according to their belief. This will, they believe, will increase tolerance, will probably bring down those authoritarian regimes. And so it was looked at very favorably by many intellectuals in the Western world. The decentralization of information is going to do only good things to open societies and inflict major harm on authoritarian societies. What happened in reality is almost exactly the opposite. The high proliferation of information, the decentralization of information, created a massive social divide in open societies, a fertile ground to manipulation, endless campaigns of misinformation and disinformation, while those open societies cannot do what other societies can, for example, authoritarian regimes that still maintain a very high level of control. So this is really the background to what we call information overload. What is information overload in our day-to-day life? Very simple. It's too much exposure to too much information, most of it irrelevant information to our survival. Extremely high volume and extremely high intensity. Think about yourselves. You wake up in the morning, what's the first thing that you do? And think about how the number of information sources have increased over the years. I remember when the internet became a big part of my life, I maybe had one or two sources of information, but today I wake up in the morning, even before my first coffee, I'm already checking my WhatsApp and my Messenger and my Facebook and my Instagram, my LinkedIn and this and that. I have like 10 or 15 different sources, not to mention the mainstream media. And our human brain was never designed to handle so many stimuli simultaneously. And it's very, very important to understand that. Now, what is the impact? The impact of information overload is dramatic. First of all, it increases the level of anxiety. People are more anxious. People are more depressed. You can see that just by looking at the unbelievable number of prescription drugs that are being produced to tackle this issue of high anxiety. When we are anxious, what happens to us? We tend to lower our judgment. We tend to make mistakes. We make errors when we are anxious. But beyond that, and perhaps the most important impact of information overload, is that we became not only co-producers of content, but we are now craving collectively. We're craving for simplicity in the face of heightened complexity. The more complex the world is, and the world is more complex through the various channels of information that we are exposed to, the more complex the world is, the more simple the solution we crave for. It's very, very important to understand that. In that context, you can understand, and again, I'm not taking any political position here, but you can certainly understand Brexit as a result of information overload, or the popularity of the idea of building a wall between the United States and Mexico as a simple solution to that problem. Again, without taking a position on this issue, I'm just making this an example how simplicity in the face of complexity is what people want. People want simple solutions to highly complex problems, and the hashtag became the new bumper sticker with only one major difference. The hashtag is ubiquitous, is all over the place. Add to that the fact that information revolution and hyperconnectivity, we spoke about now what will happen with 5G when the cellular bandwidth will allow way more information to travel from one place to another and to be connected and to connect people. Imagine what will happen then in terms of the ability of people to disrupt entire systems. Now, we always knew that political life attracted people that were self-centered. I don't know if you were familiar with the famous Mahatma Gandhi distinction that he made when he spoke about the relations between the sexes. He spoke about two extremes of behavior, of interpersonal behavior. One is all about self-indulgence and the other is all about self-restraint. This is exactly the scale that we have to look at the internet and how people indulge or restrain themselves from dealing with information. So when the hashtag becomes the new bumper sticker and the hashtag is ubiquitous and people have the ability to disrupt entire systems with one click away, which is something that they could not have done years ago, although there were also probably self-centered, not to say narcissistic political leaders, that's a problem. And as a result, we all have opinions that we all view to be very, very serious opinions. And they're all based on reliable information, whether it's the issue of whether should I be vaccinated or not, or whether Britney Spears should be allowed to handle her own financial affairs, or who is the best basketball players of all time, and what do you think about this? And we all have opinions now because we are all exposed to information that we view to be very, very serious. And unfortunately, in many cases, the information is not serious. Information is not reliable. And in many, many ways, although technologically we are able to verify the sources are not verifiable. And so what is the actual implication of it? So a lot of people talk about the rise of nationalism as a result of information overload, but the truth is that what we see is less nationalism and more the rise of populism. Political leaders that just realized that the new technology is allowing them to use a different language, a coded language. We call it the idea of populism, which is essentially it's a narrative that says, I am with the people, I'm the political leader. I'm with the people versus the others. The others can be it could be the immigrant, can be the person that has different sexual preferences, a person that has different skin complexion. It can be anyone, someone who's believing in a different ideology, but I am the people. I'm with the people. That's the story that the populist is telling the public, and we are against the others. And usually they direct their animosity against the elite or against the establishment, and they're often being led by charismatic or dominant figures. And we see that all over the world, not only in the United States, not only in the Western world, we see it all over the world. Another major manifestation of information overload and the way it changes the political discourse is what we call the disappearance of distance. Now, distance was a defining element in the relationship between political leaders and their constituencies. What did we really know about FDR? Not much. Many Americans did not even know he was a disabled person. What did we really know about Winston Churchill? Not much. Did we know that he used to stay in bed until 1 p.m. and started his morning with a liquor and a cigar, as we saw in the movie? And I spoke to his granddaughter, and she confirmed that as a child, she remembered him in bed most of the time. That was the great Winston Churchill. Information overload and the information revolution is eliminating the distance. And what that creates is a new type of political charisma. While the distance allowed what we call mystification, the disappearance of the distance is creating a new type of political appeal. And that political appeal is based on the exact opposite to distance: lack of distance, reflexivity, perceived transparency. But the most important thing is no shame. Be who you are. And that's the source of the new political attraction. And again, without going into names, when you see those political leaders all over the world, they are shamelessly ignorant. They are shamelessly lying. No regrets about lying, because this is who they are. And there's no distance. We know more than we would like to know about them. And strangely enough, that is the new definition of political charisma today. Perceived authenticity and reflexivity are the new political charisma. So what do we have here? We have too much information that is overwhelming the consumers, heightening the anxiety, lowering the judgment, creating an unstoppable, ongoing craving for simplicity in the face of complexity. And this is how we ended up where we are today. In many ways, you could say, and this is a conference about connectivity, that we are probably the most connected and disconnected generation in the history of the human race. We are connected technologically. We are disconnected through those devices that allow us for the first time in human history to self-design our own informational environment. What can we do in order to handle and cope with what we call information overload? Too much irrelevant information. The first thing is to maintain informational distancing, just like you maintain social distancing in order to avoid COVID-19. We have to exercise what we call informational distancing. You have to limit yourself to only a handful of information sources that you trust. Verify those sources. Limit the time you devote to information consumption. Limit the sharing of information with friends. You know, I have some WhatsApp groups. The kind of information that is going through there is just not only unnecessary, in many cases, it's harmful. I don't need to see all those violent videos that people share with each other. Nobody needs to see them. Believe me, I experience combat, and some of the stuff that I see on WhatsApp is much worse than what I'd seen in combat. And this is not the way it should be. And of course, embrace new technologies. NFTs and blockchain will allow us to create a safe peer-to-peer engagements. Probably this will also be the technological solution to what we call fake news. And I'd like to end this by saying, I may sound pessimistic, but I'm actually quite optimistic, because the same technology is agnostic. Technology doesn't have an opinion. Technology doesn't have an ideology, but the same technology that created the conditions to manipulate the information, to manipulate the implications and the ramifications of information overload, the very same technology will also produce the solution to that problem. And with that, I'd like to open the floor and take some of your questions. Thank you.
Thank you, Mr. Aharoni. That was an excellent presentation.
Thank you.
Right now, there are no questions from the audience. But I was wondering, towards the end, you mentioned emphasizing trusted sources and eliminating fake news, I think you said. So do you have any advice on how you could go about identifying what sources are trustworthy and what sources are not, and instead being fake?
There's a big difference between information that is being produced recreationally or for cultural purposes and news. When people talk about news, they're actually talking about facts that have a role in the political process. This is really when Donald Trump was using the phrase fake news, and he used it frequently to the point that it just became part of the vernacular. The truth is that fake news always existed. It's just that fake news used to be in remote newspapers that very few people bothered to read. But again, because information is ubiquitous and the hashtag is ubiquitous, it is much easier today for people to disrupt the system using technology. So what's the main problem with fake news? That you really don't know, or you can't verify the source. Technologically, it is possible to verify the source. If someone sent me a story that looks like a New York Times story, but someone played with it, someone cooked it, someone doctored it, then there is technology, very simple technology, that can actually help me verify whether this story was touched or not. And same thing goes for the same way, on Twitter, certain accounts are verified, which means we know who these people are. Twitter knows who they are, and therefore you can trust their information. If you're verified, is just one way of the platform to help us combat it's a huge problem of people disseminating information, especially around the issue of the vaccine. The vaccinations. And again, I'm not taking any sides. I'm just saying people make decisions, people form opinions based on information that is largely irrelevant.
Okay. Well, I still do not see any questions from the audience, so I'd like to thank you for your talk.
Well, I think everybody is anxious to go to the break now, no?
To the banquet, lunch banquet.
Thank you so much, Dave.
My pleasure. Thank you.